Yes.
I think from the error that what you have shared with me, there is something to do on the meshing module. It won't take much time. If you can show me that, then I'll help you out how to do that.
Sir, please allow me.
Oh, sorry. Yeah, I'm doing that. Yeah, now you can do that. Okay, so now go to mesh module. You are using this as a solid mesh or like go to the first one. Go to the first one. Yeah, CFR. Can you zoom this? Still, can you zoom? So you are taking this as a shell or a solid?
It's shell, sir. Because
Okay. Okay, fine. So
yes, sir. Because
then
I have to
actually,
vary its length now. So
okay,
for
fine.
partition,
Okay, okay, fine. This is for our something it is on the 1, 2, 3, 4. I'll request you the control.
Yes.
Yes, assign element type. Click on that.
Sir, you have the control.
Yeah, you have to click on this one and then select all the elements. Done. And here, what you are using is the shell only. The standard linear thing.
This is not to be assigned.
Concrete block, epoxy. Okay.
This one.
Fine. Yeah, where you see that error?
Error while assigning mesh to that. Can you part 3?
Part 3.
Yes, sir. Part
Okay.
3 part.
Oh, okay, okay, sorry. Part 3.
So
So
when I'm going to assign a mesh in this, so it's showing that error.
okay, understood. So here what you have to do, you have this particular any material removal it is there on the holes.
So material is also there.
This is a hole, right?
Yes, a whole. I guess a reinforcement.
Yeah, yeah. 1 second. Let me understand the geometry first. I think because of the graphics problem, nothing is visible here. Okay, I can see, I can guess that there are holes inside this particular thing. So what you have to do, you can
To
go to
assembly module, you can.
mesh controls, you can go. You can select this part, you have done. Instead of a hex, try to go it as a cut mesh, then just give OK. Now try to mesh that particular part.
Okay.
Okay, so this is how you can do this, but this is
It will
like
work.
huge
It will
number.
work.
That is 2,10,648 elements it is there, but that much it is not required. So you can go to the size of this. Don't go for 25. Still, you can just make it as something 35 also.
Do it 50. 50 would be better.
Sorry?
50 would be better.
Yeah, we'll see that also.
Sir,
Now it is 92,307. It's coming, but
still it's
now that all the holes that you are trying to do this, so these are all getting filling, right?
yes, sir.
Okay, so you can just go to holes like let me delete all the mesh. But I can't see the holes here. What is this? I can let me go to part. This is part 3. So part 3, I didn't see any holes, right? Why?
Sir, can you select this hole?
Which one?
Yeah, part only. Can you select the whole diagram? You will see the interiors of that.
I didn't get what yours.
Just a second, sir.
I'm just going to the mesh module again. Okay, yeah. Now I'm giving you the control. You tell me.
That's not.
So, but where this is not okay. This is not the throughout holes. On the surface, it is not there, right?
Only one. It might be on the surface. Actually, the length of the concrete and the length of the steel is same. Steel bar is same.
Then
Both
why?
are three.
Then why actually on the surfaces I can't see this? Because even this side I can't see, and even this side a little. But why I can't see that? So there is a length difference, but when you just want to go to the mesh for this, let me go and cut this. So while cutting, I think we have to cut like this. So this side I want to see, not this side. Okay. So I want this. But nowhere I can see that. What's the dimensions of that?
Sir, actually, I've made this by a wire. Then I've
Okay, if it is not in this, at least in this direction, it should show, right? See, I'm just going to only this particular plate. It's a very small plate, kind of cube. I'm going.
reinforcement I haven't made by solid extrusion. I've made by that wire through wire in part module. Then I've assigned them the cross section area.
Let me see this assembly module first. So in the assembly module,
Down.
the assembly module, I have something here. Oh my God, 24 instances that you have. There's the part 3 one, okay. Steel bar 1. Okay. Steel bar 1. Let me go here. This is steel bar, right? This is a steel bar.
Yes, sir.
Okay. If I just go to this steel bar, futures, wire. You have taken this as a 1D element, wire.
Yes, sir.
So that's why it's not showing the holes over there in the 3D.
Sir, by taking that 3D element, no, those
I
stirrups.
suggest you not to take this 1D, go with the 3D only.
Sir, actually, I was taking the 3D. So modeling these bars is easy. But while going for the stirrups are not coming of proper dimension which I want.
No, you are not doing properly that. If you go
Suppose
just as 1D, okay,
I'm
even
giving
this
it as a
particular
dimension.
one, you are going this 3.4 V3. When you
I'm giving
go
the
to
stirrups a dia of
screen,
8 mm. Suppose I'm giving a dia of 8 mm. So it's not coming that, it's coming more than that.
nothing like that. The feature has a no modified parameter. Apart from that. Okay. Anyways, that if you are confident about that, you can go. For meshing this particular part, you can able to use this. What's the diameter that you are choosing here?
It's 12 mm.
The 12 one. 12. It's a 12?
Yes, sir, 12 mm. 1, 2, 12.
Okay, so you can just go at least like 12 mm diameter around that. Like if you need something, you can go something like around 10 mm also. Apply. Okay. And later on that if you just want to see this one by holding the shift, you can select this. You can select this. You can select this. All things that you can go and you can see this approximate size on this particular things is right. So by number you can go. It was showing 340 as the number. So just make that to like something around 150. Line. Okay. And if you want, you can generate a mesh.
So attaching these reinforcement to the concrete. So we have the constraint which I used was embedded one, and tying those stirrups and those bar I used tie constraint.
But those are like tied ups only, right? So you are using tie constraints. So tie constraints need not to be a same node numbers and all. It can be any node numbers.
No, I was asking about the embedded one. So
It's
attaching
like 6 lakh 1 to, oh my god, 60,000. It's like a lemon just creating. This is too dangerous. So we can just go again. 1 second, Bianca. Hello. Hello. Okay, so మీకు చెక్ చేయి బాబు అని ఏ రోజు చెప్పినాను. 2 వారాల తర్వాత వచ్చి వాళ్ళకి చెప్తే ఏమంటారు? ఎక్కడ వీళ్ళ దగ్గర నుంచి తెప్పించిన పాట నుంచి వెళ్ళి రాజేష్ అన్నకు ఒకసారి ఫోన్ చేశాడు. సరే నేను చెప్తాను. సరే సరే. ఓకే సరే. వెళ్ళు, లేకపోతే నువ్వు బావ దగ్గరికి వెళ్ళు, అక్కడ నుంచి ఫోన్ చేసేస్తారు కదా. జస్ట్ ఒక చిన్న మీటింగ్లో ఉన్నాయి, కాల్ చేస్తాను. హలో ఆశిష్.
Yes, sir.
So this is creating a more number of an elements. I think delete the mesh. Delete the seedings also, that whatever you have.
So do the results will vary if I go for 1D and 3D between them?
Yeah, obviously.
Will they vary drastically or a subtle difference?
That I can't comment because first we need to see. Okay, better you go with 1D and then check it how it's behaving. So based upon that, like you can able to decide next. Okay. But the geometry, this is not so great. I can comment on that. If you go proceed with this, the same geometry that what you have, this holes at least like if it's a 12 mm diameter hole, it should be visible for me, but it's not visible over here. How you have achieved that? I think I don't know. So if you can visualize, if you can go through my videos that I already have told you.
Yes, sir.
Okay.
I made that from assembly, merge and cut, so I use that only.
Then, but still, like, how come the part it is going to be in this? At least, like, once if you are using that particular way, when I just go to part module, if I see this, at least I should see that, right?
Yes, sir.
So it's not properly done then. So you can try to work out this assembly merge operations again. That may help you.
Hello.
Hello.
Yes, sir. Yes.
You got me right?
Yes, sir. Yes, sir.
So I
So,
need, so do something so that I can see the holes over here also.
okay,
Unlike,
that will be the, those holes are visible only
but
when that is done on 3D.
yeah, you have to done on 3D only. At least see later on your steel bars can be replaced with 1D. That's not a problem. That's not going to
Yes,
be
sir.
at all a problem. But at least to model that like holes onto this particular part 3, you have to do 3D. There is no choice of that. There is no deviation on that. You have to, must and should. Okay.
Yes, sir. So one more thing.
It is must and should. First, bring that particular 3D and then make the holes of here. Later on, that is your choice in the analysis that you are going to utilize the 3D still, or like you are going to just use a 1D beam elements over there. That's your wish.
Yes.
If you do a 1D
Sir?
removal, then what is going to happen? Nothing. In the thing separations, there is nothing is happening over there.
Yes, sir.
See, I recommend you to go with the 1D elements also. There is no problem. But first, you have to create a 3D to make the geometry. If the geometry itself is wrong, then what is the point of looking into the results as to the correct results?
Yes, sir.
So try to make that, and then we can see how to proceed further.
Sir, one more thing. If I need to feed this data as a cyclic load data in this, so how to do that? It's a displacement versus time curve.
Yeah. So the time that in your static analysis that you are considering the time as your Newton Raphson time. So first thing, you just copy all these particular values and put it in an amplitude.
Can you tell, sir, in the step module?
No. Amplitude is there, right? So in the model tree that you can see an amplitude. Yeah. First create that, name the amplitude that whatever you want. Okay.
Then
you can continue. It's a tabular one only. Continue. Paste your x direction values under the time, your time values under the time, and your amplitude values. That means your displacement values under amplitude. You can copy both at a time and then paste, no issues. Okay, you okay? And now go to load module, that where you want to apply the displacement. I told you that like you have to apply this onto your reference point, right?
yes,
Okay,
yes.
but reference point you have not created, so don't no worries about that. I'll show you to on one point. I'll show you that, but later on you have to do it on your reference point. So you can just go to your load module. Sorry, not this displacement. Create a displacement boundary condition. So you can choose this one. So displacement rotations that you can select this, and let's say onto this particular point that you are trying to apply the loads. I'm selecting that particular point. So just give done. After giving that in which directions that you want to apply this particular displacement, you can select that one. So by default, I've selected this as an initial, but don't worry. I can select this. I want to apply it in Z direction. So I can just click OK. And if I just go to the manager, it shows that it is created an initial because I have no steps created here yet. I have no steps created here yet. Okay. So once you create a step, then in that particular step, it's going to show that particular value. So let me create a step. So it's a static general step that I'm doing it. So non-linearity geometry on increments. I can go. I can start with some 0.01.
So whatever the load we are applying, the incrementation should be start from 0.01 only.
It's 0.01. Sometimes it is 0.001. You have to go trial and error for that.
Okay, sir.
Okay. So now test this here. Go to load. So already you created that, right? So I'm just moving that to your right. So now in this, the displacements here, I'm just going to give it as like a 1. And this one should be multiplied with this particular amplitude. And then just give OK. So now whatever the compression negative values you have given, it goes under a compression value, and positive values that which you have given, it comes under a tensile values.
Sir, actually, one thing I was wondering about that. As it is a column, no, so it is fixed from both the ends. Above, it's a ground floor column.
Yeah.
So it will be fixed from upper end also and lower end also. So
okay.
we need to give both the boundary conditions in this, no? From base also.
Not required. Not required. In reality, that is the case actually. So if it is Then how come the load it is coming? If the top end is fixed to some other source, right? That is onto the slab it is connecting, right?
Yes, a beam is connected to that top surface.
Yeah. So what is the load generation point with the beam, right?
Yes.
So the load.
So
So you are giving that load. No, only on the bottom that you are fixing, and then at the top you have to apply the load.
okay, upper end we don't have to fix, no?
Yeah. But you can do one thing
Yes, sir.
to simulate that. You can arrest all the other degrees of freedoms. All the other degrees of freedom is arrested. Only compression and tensile load it is got applied. Okay.
Okay.
Like that you can able to define that. You got it? Ashish, can you share your screen? I'm sorry, in the middle, it's an internet problem.
So I was asking that you said no, it will be arresting the other degree of freedom. So that will be only in this particular point or whole plane if we are arresting that.
Your reference point is connected to the whole surface, right?
Yes, sir.
So it will be applied to the whole surface.
Okay. Actually, what I was trying to do is that to create a reference point here
Why?
in this plane. It's a lateral node. The load will be applied laterally. No? It's a column. So cyclic load just to
No.
simulate an earth.
You create on the middle of that, and you, if you want, you can apply the lateral load also.
Okay.
Can you give me the control?
Yes, sir.
Lateral load also, that if you want, you can apply that. Like lateral load that you have, it's a combination of a load, if you say. You can apply both, right? See this.
Okay. Okay, this will act both as laterally also in upward direction.
Yes. But
Okay, if I just want to apply it laterally, the cyclic load only laterally. Sir.
okay.
So
Yeah, that's what I'm trying to tell you. So in that particular cases, you can able to do only cyclic loading cases once. Okay.
yes, sir.
And the other one actually you should use only a static load case. Separate analysis that you have to do.
Okay, sir. Hello.
Yeah.
Yes, sir. Mhm. Now what to click in this, sir? Should I one is X? Should I make this
So
0?
first correct
Suppose
the
only
geometry. First correct the geometry,
yes, sir.
and then come back to me. Like I'll show you like how to apply this loading.
Yes, sir. Sir, one more thing I was asking. With that steel one. So it was showing this error.
Can you go to boundary conditions?
Sure.
Yeah, close this one. Go to this loads module. Go to
Yes,
the first manager. Create load manager. Yeah.
I've removed the load, sir. Actually, I was trying to model it again. Na. So what I earlier did was that I created a reference point here, and I kept a 500 kilonewton load here. And
That's what the problem actually. I think now you have changed the geometry. That's why the loading it is not showing.
And then I kept this base area fixed. Then I ran it for analysis, so it was showing error. Earlier, I did it for different model. It was running, but similar steps I used here. But here it's showing some errors.
That node, whatever the node that you created it, that is not sent properly. If you can show me that node, then I can tell you what is it.
So which node?
Whatever the reference point that you have applied, you have. Can you run this analysis? Are you getting the same error?
Then I have to create the load.
First run this. Oh, no. Don't create the load. First run the analysis. Data check you can do.
Without any section assigned. Okay.
Now there in the parts, it is not showing anything. Why here? Here. Yeah, that's fine. Okay. Chal.
Yes, sir.
Okay. ये कंपनी में मिलते सामान देता स्पेयर्स लो मैं मीटिंग లో ఉన్నా మీటింగ్ లో ఉన్నా నీకు కాల్ చేస్తా చేసేవాళ్ళన్నా సరే No. You have to create a new point and then you should call that point as an RP point and then you have to choose that.
Sir, it's boundary condition.
Oh, fixed one you are doing, but okay, fine. You can do
Yes.
that. Then why you selected that point separately? You have to select only the surface, right?
I've selected the surface only, sir.
Okay, then do.
So the reference point will be created by this one only, no?
First you create a point. Yes, you can create a midpoint.
So suppose this.
Yeah.
Let's create.
And you can go to interaction module.
Just click this.
Yeah. Okay, and then go to for tie connection constraints. There only the interaction module only. Coupling constraints.
Sir, actually, earlier I did with simply this. I created a reference point and I added a load in this. It was running.
It will run. The thing, when you go for a coupling, whatever the load you applied, everything will be uniformly distributed to all the nodes.
Okay, sir. Continue. In this point only, sir?
Yeah. You can select that as a master point. And you can name that point. M set to, you can't identify it, right?
Select the surface
and choose the surface here, that which it is connected. Yes, done. You are selecting the wrong surface. Why? Yeah. Name that. Name that.
done.
Yeah, done. Done. Okay.
Continue kinematic.
Nothing. You can leave it default. Yeah.
Now on the load module, sir.
Yeah. Now go to the load. Go to displacement. Displacement. You are not applying the load. When you apply the load, we have seen errors, right? So go to displacement. Yes. Yes. Go to displacements. And no, cancel this. Go to there, select step not initial. You have to apply it for the step 1. And then yes, yeah. Choose continue and select this reference point, or like go to sets, click on sets, and choose your master load. Continue. And now apply the displacement.
Displacement.
Yeah, whichever the directions that you want, apply that.
So displacement will be, suppose I need to apply the load. Now I have loading details. Suppose 500.
Apply the displacement. That means in the basic equation of F equal to K into X, you are trying to calculate the force by giving the displacement as an input. Okay. So now give the input as a displacement, and for that particular displacement, what is the force it is coming, you can capture that.
Okay. F equals Kx, where K is the stiffness of this hole.
Yes.
And X is the displacement.
Yeah. Give that value. You give some 2, 3, and then you can check what is the load it is coming as an output. 500 mm, it's a huge displacement. Half a meter. 5 mm is also huge actually in for a beam. If it is bending like 5 mm, yeah, You can just keep it as a 1 mm just for trying, right? Yeah, okay. Okay, so now you try to solve this. Meshing, everything is done.
Meshing is, so the direction is opposite. So we have to change this direction.
Change the direction, you can keep that value into negative value. Go to displacement.
Again in the displacement.
On the manager,
Okay.
you can click on this manager, you can double click on this and on this, you can change the negative value if it is a compression.
Okay, sir. This is good. Now should I run it? Data check?
Yeah.
Okay, so. So how to change the value of these? Hello?
Hello.
Yes, sir. How to change the value of these? It's coming in E.
How to change these values? Okay. Go to viewport at the top. Viewport, the left side one. Yeah. Viewport annotation options.
Edit.
Viewport annotation options. Legend. And under the numbers, you can see format, right?
Yes, sir.
You can click to fixed. Apply. Okay.
Okay, sir. So in this one more thing I was asking that suppose I created a reinforcement for attaching that in concrete, I'm using embedded one, embedded constraint. Hello. Sir.
Yeah, 1 second. 1 second. Yeah, tell me, Santosh. Ashish.
Yes, sir. I used for attaching the reinforcement uh, this embedded
No,
region.
no, 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 no use of MPC. MPC also you can use it, but it was like a little older option. You can use tie connection, no issue.
Okay, tie for no, sir. Attaching the reinforcement to the concrete.
Yes, yes, you can use tie for anything, no issues.
Okay.
Only for load distribution that you need coupling, but you other than that you can use tie.
Okay, sir. Mm. So I was talking about this.
The person you have called is speaking to someone else. You can wait for call again later. మీరు కాల్ చేస్తున్న వ్యక్తి మరొక కాల్లో బిజీగా ఉన్నారు.
1 second, be online. Ashish.
Yes, sir.
Hello. Hello. Ishwar. Hello. యా, అది ఇవాళ రమ్మని చెప్పారు కదండి, నాకు లొకేషన్ షేర్ చేస్తాను. ఓకే, ఎప్పుడు చెప్తారా మళ్ళీ? మీరు నాకు డేట్ చెప్తే నేను మళ్ళీ ఆ డేట్కి కాల్ చేస్తాను. నాకు మళ్ళీ మధ్యలో డిస్టర్బ్ చేయడం కూడా ఇష్టం లేదు నాకు. కాదండి, 3 ఏళ్ళు నేను వెయిట్ చేసి 3 సంవత్సరాల తర్వాత నేను మాట్లాడుతున్నాను. నేను ఇప్పుడు కూడా మిమ్మల్ని డేట్ అడుగుతున్నాను నేను. ఓకే, అవును, 2 నెలలు ఏమైంది? మీరు 3 ఏళ్ళు టైం తీసుకుంటున్నప్పుడు 2 నెలల గురించి మాట్లాడుతున్నారు. పోనీ 2 నెలలు అయిపోయిన తర్వాత ఎన్ని నెలలు మాట్లాడారు మీరు? ఇప్పుడు మీకు ఏ సంవత్సరం ఏ 2 నెలలు మేము తీసుకున్నాం చెప్పండి ఒకసారి. మ్యారేజ్ అయ్యింది 2018. నేను 2021లో మాట్లాడుతున్నా మీతో. మీరు అడిగే దాంట్లో లాజిక్ ఏ లేదు. నేను 2018 నుంచి 2019 దాకా మిమ్మల్ని అసలు డిస్టర్బ్ చేయలేదు. 2019లో మీరు 2 మంత్స్ తీసుకున్నారు, ఓకే. మీరు 6 మంత్స్ తీసుకోండి. నేను సెలక్షన్ కి 2 మంత్స్ తీసుకున్నాను కదా. మీరు 6 మంత్స్ కాదు, 1 ఇయర్ తీసుకోండి చేసేకి. 1 ఇయర్ తీసుకోండి, నేను కాదనట్లా. నేను 2020లో మాట్లాడలా మీతో, నేను 2021 ఇయర్ ఎండింగ్ లో మాట్లాడుతున్నాను. చెప్పండి ఇప్పుడు. 2 నెలలు నేను లేట్ చేసిన దానికి మీరు 3 ఏళ్ళు లేట్ చేస్తున్నారా? మీ లాజిక్ అదే కదా మీరు మాట్లాడింది. నేను మిమ్మల్ని అడిగింది, మీరు బయట వాళ్ళకి చేసుకోండి, నేనేం ఆపట్లేదు. ఈ రోజు ఇస్తున్నారా లేదా? మీరు ఎప్పుడు అడిగారా ఏంటో లేదండి. హేమంత్ మీకు ఫైనలైజ్ చేసి ఇచ్చిన డేట్ చెప్పండి. కాదు, మీరు మీ తప్పు ఒప్పుకోవట్లేదు కూడా. జనవరి 10 ఏ సంవత్సరం? జనవరి 10 ఏ సంవత్సరం? మేము తప్పు చేసామంటున్నారు కదా 2 నెలలు అని. మేము 2 నెలలు ఏ సంవత్సరంలో కన్ఫర్మ్ చేసాం మీకు చెప్పండి. మీరు మమ్మల్ని అంటున్నారు కదా తప్పు చేసామని, మేమెందుకు ఒప్పుకుంటాం? 3 ఏళ్ళ నుంచి చేసుకుంటానే ఉన్నారా మీరు? మిగతా ఏమీ ఇవ్వలేదా డెలివరీస్? మీకు రూపాయి ఏమన్నా లేట్ చేసినామా మేము? మరి మీ తప్పు మీరు ఒప్పుకోకుండా మా టైము వేస్ట్ చేసుకుంటా. మీకు ఇప్పుడు మేమేమన్నా పెండింగ్ ఉన్నామా చెప్పండి? కాదు, మీకు ఇప్పుడు ఈ మినిట్ లో మీకేమన్నా పెండింగ్ ఉన్నామా? పెండింగ్ ఉన్నాము అని చెప్తే చెప్పు, నేను కాల్ పెట్టిన వెంటనే ట్రాన్స్ఫర్ చేస్తాను. నీకు ఎంత? మరి హేమంత్ డబ్బులు మీకు ఇచ్చి కూడా సంవత్సరం పైన అయిపోయింది కదా. ఇప్పుడే హేమంత్ లైన్ లో పెట్టానా? సంవత్సరం పైన అయ్యింది. హేమంత్ మీకు డబ్బులు ఇచ్చేసి సంవత్సరం పైన అయ్యింది. మరి సంవత్సరం తర్వాత కూడా మీరు ఇంకా 2 నెలల గురించి మాట్లాడితే నేను ఏమన్నా Ashish,
Yes, sir.
yeah, tell me. It's been like 3 years I got married, but still now I didn't got my marriage album.
Sir?
Okay. And regenerate, go to future and regenerate that particular option, then automatically everything can be displayed.
Okay. I was asking this instance.
And the distance is 342.
The dimension was given 350.
342.7 it is. Here it might be haven't taken a 350 only, but it was like roughly that dimension change it could be happen. That's not a problem, I think.
That was that only the doubt I was getting, that actually
No, no,
the
no, no, no,
figure
no.
equation.
Basically it is taking 350 only, but
Okay.
the lines that you are representing, right? So that is creating a problem. So no issues. You don't worry on that part.
Okay, that was only the doubt going for 3D.
No issues.
And one last thing, sir.
Yeah.
This in this, how could we know that failure analysis? Sir? We have to do suppose a failure analysis and what load it's getting failed, compressor load.
Yeah. So to identify the load, actually you can click on this XY scanner, or like you can just go to this RF under this. You can just give me the control.
Yes, sir.
You can click on this and you can click here for RF. So this is the force actually that totally you can able to plot this one. So this is the force. You can stop this. For 1 mm displacement, what you can see is these many number of newtons, 18,172 newtons.
Okay.
So now try to reduce that 0.5 mm. So you can see like might be around something around 8,000 or 9,000. Like that, if it is like 500 newtons, hardly the displacement might be around like 0.01 or 0.05 like.
And how to get the reactions? Which reactions are being generated?
How to get the
reactions which are being generated in this?
Oh, I didn't get you.
The reactions are
Meet nodal,
yes,
magnitude, elements, node sets, and then you can just go, it's a master load, so you can just plot this curve. So this is what actually, see the force it has got stabilizing, it's keep going on, and after that it got completely stabilized. See this one, see the curve. Yeah,
yes.
you could able to see the curve, right?
Yes, sir. Yes, sir.
Okay, so the force it is going and it is getting stabilized, those particular things. So the amount of the load it can able to take it up to this. After that, the huge amount of displacement it is taking it, and then suddenly the part may get collapsed. Okay.
So the force is reduced value, because 15 Newton is not
15.
This force.
It is
Which is
15 E3. 15
okay.
E3.
Okay. E3. Okay. That means 15,000 Newton.
Yeah, 15,000 newtons. Normally, structures won't display like it won't deflect about like 2 mm or 3 mm like that. It's hardly deflect around like 0.01 mm or 0. If it is like a 1 mm displacement also, people may feel that like some kind of earthquake is coming.
Sir, every time we have to go with this displacement only, why can't we apply the load directly?
Yeah, that's where when you are solving it for f equal to k into x, for some of the problems, matrix division is quite comfortable. So it will solve and it will give it to you. But in some of the cases, matrix division is being a biggest challenge for this kind of a profiles. So in that particular cases, you have to go for matrix multiplication. So matrix multiplication means like anyway stiffness, it's going to be calculated by the software and it has to be multiplied with the displacement value that we are giving it, and then it will calculate you the force. But if you give the force as a value, then your force matrix has to be divided by with your stiffness matrix. So sometimes matrix division being a challenge, that's why it's throwing up your errors.
Okay, sir. Okay, sir. Thank you, sir. Tomorrow at the same time we'll be free. I'll be coming with the 3D model.
Tomorrow, a little early also, we can meet up, no issues. In the evening around like 4 to 5, like that, we can catch up.
Okay, sir. Okay, sir.
Okay.
Thank you, sir.
Yeah, okay. Same.